you actually have a couple of dangers here, right? I mean, one is that if you do something to leave the connection up all the time, and even if it's not really up, you run the risk of like your application or your client application believing that the server side is available even when it's not, and I'm sure that leads to non-desirable situations and what we're talking about here. And then second is there, I was thinking about, is there like retry logic or something on the other side, or why isn't it just like when the connection gets dropped, it retries a bunch of times and reestablishes to the new pod that brings it up? Like that seems like a much simpler solution.
Just rewrite the whole thing in UDP. Get that done next week.
I'm not suggesting that, but I have a lot of experience kind of with low-level networking things, and when you try to fool, like, I mean, the whole idea is like when that drops, like when your server side drops, like in the TCP protocol, it's actually going to send like a reset, like an RST, right? Because the actual like packet is gone, and that endpoint is no longer there, and that's actually what's like it's behaving as intended. So you're trying to like circumvent what TCP's real job is doing, like somewhat in this case, right?
Yeah, and they do reconnect. It's something where that does happen, but I think that it's something that we've been trying to think about from the perspective of, we want to start doing, for this specific client, I want to start doing blue, green, or canary, and which means I'm going to be like swapping out connections a lot. And therefore those connections do have real world impact on the customers that are at the other end of that tunnel.
Sure.
So I think that, the connections will, reconnect, and that's not the issue. It's just that it has ramifications on the actual application's capabilities that I was hoping that, something that could, live in the middle and manage that a little bit more intelligently would be the way to go.
So, and this is like more like on the category of terms to Google side, a pattern that I thought was really rad. The project has stalled out 2 years ago, so I don't think it's alive anymore. I got into this back in 2010, so almost 10 years ago, or maybe it was 7 years ago, maybe, or no, 10 years ago, sounds about right. Mongrel 2 was a re-implementation of Mongrel, the web server, in a very interesting pattern. And behind the scenes, it's using 0MQ as the message bus between the servers. And the job of Mongrel is simply just to ingest the data and stick it into ZMQ. And then you have consumers of ZMQ processing and sticking the response back into it. And yet it supports WebSockets and long-lived connections and things like that. Now, I don't know what this is for specifically HTTP. You were saying TCP, I think, maybe. So I don't know if you were thinking HTTP over TCP or if ultimately it was just HTTP.
Yeah, it's just a TCP socket. So it's at like layer 3 or it's at layer 4, which makes it more difficult. And yeah, I mean, that's the thing I keep running into is folks are recommending things that are at like, layer 7, like WebSockets. And when you're dealing with legacy client interfaces, it's just, you don't have the control. But this is a good, I'll look into that just from, checking it and like seeing if there's some follow up to that project, because it seems like somewhat similar.
Or maybe somebody may be solving the same kind of thing somehow through TCP. But I don't. The fact that you're trying to solve it at layer 3, layer 4 in a generic way. I don't see that happening. To Matt's point there. The reason why these things are at layer 7 is for that reason, that you are in control of the application logic.
Yeah, the only thing I know of that might help you a little bit would be, I know in Calico, as an example, they have this thing called like a floating IP, I think, or something like that, where it basically presents a workload IP that it keeps alive all the time, and then like basically redirects it to the pod that hosts it. So like they do some sort of trickery under the hood where you have like a static IP address kind of in the cluster that gets then used to redistribute traffic to other pods in the cluster. So it might be something along those lines that might be able to keep it up, or do something like that.
I think that, yeah. So I was directed by an AWS solution architect to look into app mesh, and app mesh has an idea of virtual nodes, which
idea,
sounds very
yeah.
similar.
Yeah.
That could be something I want to go down. I have to look into it more. The whole load balancer controller and service mesh discussion is one that I dug into, and it's painful as well. Anyway, thanks, folks. I think this was useful.